Hi everyone, this is the Math Nexus, and today I'm going to start with the IGCSE and O level advanced. So, the first topic we are going to counter is functions, and the main objective of this specific video is to solve exercise 1.1. And the main concept we are going to counter in this exercise is mapping. So, what is mapping? Now, mapping is actually a process of matching the element of one set with the element of another set. So, if we see in this example that 1 itself passes through a specific rule and is connected with the another set in the form of an output. So, we give an a value as an input and we get the value as an output, another value as an output after it passes through a specific rule. And if we see right here x, this is the basic format of reading it as x is mapped to x plus 1. So this is the basic format. If we see this arrow here, then we can say that this is mapped to x plus 1, and it can be different equations according to the graph or diagram. So as always, mappings can be represented through mapping diagrams or graphs themselves. So this is an example of mapping diagram, and this is a graph. We all know what graphs are. Okay, so what can be the real life examples in which mappings can be implemented? So actually mappings allow us to find out the relation between two different set of values. So it can be used in weather forecast, how they can affect the population and how many employees may come if the temperature rises. So these are some common uses of mappings. So there are different types of mappings which consist of one, many, and one, many. We're going to discuss this. For the example of one mapping, in this type of mapping, we give one input value and we get one output value. Simple, easy as that. One input value and one output value. In terms of many values, mapping, we give in two different values, and from those two values we may get one output. So for example, I take it to be x is mapped to x squared. Okay, and if we assume the value, we take any two values, for example -2 and 2. Okay, I'll just discuss why I chose -2 and 2 specifically for this example. So now if we just find out this, we say this -2 squared is equals to 4 and 2 squared is equals to 4. And as we can see, for two different input values, we get one output, one same common output. So the reason for me choosing -2 and 2 specifically was that we already knew this is a squared function. So, and if we know that if we square anything, if we just multiply negative by negative, we get positive. So I was sure that whatever negative value I would give in it, it would give me a positive value. Okay, so that's why I chose -2 and +2, because I got the fact that the same answers would come. If I would have chosen, for example, 2 and 3 as the two input values, the answer would not have been same, because I will just show you right now, in fact. we just input 2 we squared, we get 4. And if we just map it to 3 squared, we get 9. So there are some specific value for which the many-one function mapping can be used. Okay, now on to one-many mapping. Okay, so one-many mapping means that for one input value we get two output values. For example, we have the equation that x is mapped to plus minus under root x. It's given in the example actually. So if we just take one random value, because it's one many, so if we just take one random value, we get x plus minus under root 2. So for one input value, we are getting two output values in the form of plus under root 2 and negative under root 2. So that's, and specifically if we just take the 4 as the input in this type of mapping, and we get the answer plus minus under root 4, which will be equals to positive 2 and negative 2. So for one input, we are getting two different outputs. So this comprises of the one-many function. Okay, now on to the exercise so that we can solve it. So proceeding towards the exercise 1.1, we are going to solve question number 1 first of all. And as we can see, this is the basic format we have learned to tell that x is mapped to x plus 1. So here it is, x is mapped to x plus 1. However, there are conditions given to us. This E sign means that it belongs to a specific group. So x belongs to a specific group. What is the group? And this R means real numbers. So the condition is that x belongs to a group of real numbers. So what are real numbers? Real numbers are actually any number we can think of. So first of all, it can be integers, fractions, positive values, negative values, anything we can think of are real numbers. And if we go on with real numbers, we can have limitless possibilities. We can go -1, -2, -3, -4, 1, 2, 3, 4, 5 on to infinity. So real numbers have that usage. And if we similarly, to solve this, we are asked to find out whether each of these mapping is one-one, many-one, or one-many. So we are so we want to find the type of mapping. This can be found graphically. However, it is much more easier to just find it out by giving in two input values and just taking out the relation it has with the output values. So again, we are going to take any two random values. It can be 5, 3, 6, 3, 4, 2, anything. But I would prefer if you take one negative integer and the same positive value of that integer. This is because it allows us to find if any mapping is one-many in terms of quadratic equations we discussed earlier. So now if we just input -2 here, x is mapped to -2 plus 1, which is equals to -1. Okay, and if we just go similarly, x is mapped to positive 2 plus 1 is equals to positive 3. And if we see here, for two different inputs, we are getting two different outputs. And if we find the relation, we find out this is a 1-1 mapping. Easy. So on to question number 2. And if you just see that x is mapped to x squared plus 5, where x belongs to real numbers. Again, any two input values, preferably negative integers and the positive value of their same integer, -3 and +3. And if we just say that x is mapped to -3 whole squared plus 5, okay, this gives us the answer 3 3s are 9, but it's going to be +9 because negative multiplied by negative is equals to positive. So +9 plus 5 is equals to 40. And for the second type of input, we get 3 squared plus 5, which is equals to again 14. So if you notice, for two different input values, we are getting the same output. So if we take that, this is going to be a many one type of mapping. And on to question number 3. In terms of question number 3, if we see here, it's saying x is mapped to x cubed. So this is a kind of different type of question. If we see here, we take any two random values, again -3 and +3, and if we just say x is mapped to -3 cubed and x is mapped to +3 cubed, so the answers are gonna be different. Why? Because negative multiplied by negative is equals to positive, but if we again multiply it by a negative value, we get negative again. So -27, and this is going to be +27. So if we see, for two different inputs, we are getting two different outputs. This will again be a 1-1 type of mapping. I know this is quite easy, but the advanced levels are going to come as we go through the chapters. So, and if you just master the basics, it would be quite easier to solve the advanced concepts of maths. So question number 4, x is mapped to 2 to the power x, where x belongs to a group of real numbers. Again, we are going to take two random inputs, -3 and 3, and if we just input x is mapped to 2 to the power -3, so we are going to get 0.125. And if we just say x is mapped to 2 to the power 3, so we're going to get 2 2s are 4, 4 2s are 8. And so if we see, for two different inputs, we are getting two different output values here. So again, this is a 1-1 type of mapping. Question number 5. We are told that x is mapped to 1 upon x, but there's a difference in the conditions. X still belongs to a group of real numbers, but x is greater than 0. That means we do not take the value of x to be negative. So instead of -3 and 3, we are just going to take any two random integers, 3 and +2. And similarly, if we just say x is mapped to 1 upon 3, x is mapped to 1 upon 2. So if we see again, for one input there is a different output, and for another input there is another different output. So again, this is a 1-1 mapping. And again, you can choose any two random input values, and even you can choose 3 input values if you want, but 2 are enough, more than enough actually. And you can choose 5 3 6 3, any value you want for as input. Again, question number 6, we see that x is mapped to x squared plus 1, where x is a real integer and x is greater than equals to 0. So in this type of mapping, we can take the value of x to be 0 or greater. So if we just take two random input 0 and 2 again, so x is mapped to 0 plus 1 is equals to 1, and x is mapped to 2 squared means 4 plus 1 is equals to 5. So again, two different inputs giving out two different outputs. So this is going to be again a 1-1 mapping. On to question number 7. And if you see here, we see that x is mapped to 12 upon x. And again, x is a real number and x is greater than 0, but it does not include 0 because there is no equals to sign with the greater than symbol. So we say that two input values again, 2 and 3, random values. X is mapped to 12 upon 2, which is equals to 2 1s are 2, 2 6 are 12 is equals to 6. And secondly, x is mapped to 12 upon 3, which is equals to 3 1s are 3, 3 4s are 12. 4. Again, two different inputs, two different outputs. Again, this is going to be a 1-1 type of mapping. Okay. So question number 8, which is the last question. And if you see, this is a different type of question, that x is mapped to plus minus x for x, and x belongs to a group of real numbers and is greater than or equals to 0, meaning no negative values. So now any random input, again 5 and 6. So if we just say that x is mapped to plus minus 5 and x is mapped to plus minus 6, and if you see here that for one input we are getting two outputs, and for another input we are getting another two outputs. So that means that if we just say this is a 1-many mapping, and this commences our exercise. So this is the most basic exercise of this whole book, and as we go further we are going to see more advanced concepts. So that's all for today. Thank you.